seminar. Today we'll have a seminar with two speakers, Raman Kazanyakin and Navat Khurshid. They both work in service-oriented applications such as FTK, and in particular they work on the SmartCampus project, of which Raman is the Chief Technological Officer. And today they will both speak about the SmartPlanner engine and the engine that implemented the mobility-related function on SmartCampus.
Can you hear me? And now? Yeah, okay. What we'll present is the SmartPlanner engine, which is a very important component of the SmartCampus platform and the project, and it enables the functionality about the mobility-related services, and provides the core component, core basis for implementing those applications and features that you have seen in the project. So we will have three parts in this talk. First, we speak about the smart mobility services and the tools needed to implement them. Then Navas will present the SmartPlanner engine more in detail, so how it should be implemented and what we are doing in this direction. And finally, we'll conclude this exploitation of the engine in different settings. One of which is the SmartCampus project, and another one is the use of the engine in the Vivi Fiemme application that was created for the championship of winter ski sports that had place this winter in Vivi Fiemme. So, more than 1 year ago, like in the beginning of the project, we started with this idea that we needed to implement smart mobility services. So we want to provide ways to deal with the mobility in Trentino for the students, for the citizens. And what does it mean to be smart? It means actually that we have to support different modalities of public transport, and not only private transport, but also public. And we know there are several of them, different stakeholders. You can think about the Trenitalia, the Trentino Trasporti, and so on. We want to enrich all this kind of reasoning of the public transportation with the real-time information, so about the delays, about the situation with the parkings, about the situation with the roads, and so. And we wanted to go beyond this. We want to involve also actively the users, so for the users to participate to the creation of the content, to see all the problem, to share the experiences, travel, and so. And provide also means for the social mobility, which are the new means of transportation. And here you can think about the car sharing and carpooling, walking bus, systems like Django, and so on. And of course, not only provide the means and the information before you trip, but also while you trip and while you continuously take the same trip day by day. So to provide continuous in-journey support, being able to communicate to the user information important for the travel, like the delays or changes, and so be able to support him for to reserve places in transport if possible, to book parkings, and doing things of this kind. So these were the ideas we wanted to realize in the system, and of course we needed to. And in the core of the function in this functionality is a multi-modal journey planner tool, which is well, basically it's very simple thing. It is a tool that given the origin and destination of the trip and some personalization, optimization criteria. So, for instance, preference of fastest path, preferences for types of transport. You get one or more route suggestions, possibly crossing different methods, different transportation networks. So you can involve in the same trip the public transport, walk, public transport provided by different companies. And according to Wikipedia, there are actually two sets of features that these kinds of tools implement normally. So basic features include, of course, journey planning itself. So how to reach, what is the path and timing of reaching place from the origin. It should include information about the public transport of stops, the timetables of the places, intermediates, routings of the roads. It should provide some user interface to this, maybe more But you can also have some advanced features, so it may speak about real-time information, so the lead timetable, the situation of the road that it is at the moment of taking incidents, strikes, and so. It can provide information about pedestrian routing and bike routing, taking into account not only the distances but also the elevations of the landscape model of the territory, which influences a lot these means of transport. It can provide some kind of real-time prediction and timing, so it can give you some insights of how long it can be, taking the experiences of previous, the history of this kind of trips taken a certain period of time. It can provide the facilities, information about the facilities and stops, which is very important for accessibility aspects, like for disabled people, for some specific needs. And of course it can provide the information about the fares, about the zones of certification. It can provide the information about how much it will cost for you to travel, and it will be able, for instance, to provide information about carbon footprint, so how much CO2 you can use, or you can say you contribute to the pollution, environmental pollution with the vehicle. So these kinds of information are something that you can encounter in different journey planners. And there are plenty of them. One of the examples you can probably have heard about is the Google Transit, which works also in Trento and provides some types of transportation. Not all of them, for instance, doesn't include the regional trains into account, but it covers the public transportation, Trentino Trasporti, and it can help you for routing. It provides quite a basic functionality about the routings, how to reach the place, and which means of transport you will take. There are some nice features in other places, like for instance in London Journey Planner. They, of course, they have more forms of transport, but what is important, they have options to support the accessibility and parameterize your trip planning according to your specific accessibility needs. In Stockholm, for instance, they give also the historical kind of information, the information about the cost of the trip and on carbon footprint. So these are some nice examples of what is done. So there are many journey planners around Europe and also in the United States in different areas. And we also have them in Italy, like there are regional ones for Liguria and Toscana, which along with the planning provide some additional information about the road situation, the work in progress on the road and so. And of course there are some specific cities like Milano, like Rome, covered very intensively by the plans. So these are tools that are used, and of course they provide a lot of benefits for the users, for the end users, and for the community. For what concerns the users, the main benefit is that you are very efficient when planning the thing. So you don't need to open different timetables and from different providers, take time, lose time to compare, to understand how to do it. You just go there and plan for a trip in a certain zone where you normally take the things. And when you're informed, if you have real-time information, so you can have more efficient decisions, and you can know what to do in case of diversions and some problems. So, as I said, you have seamless integration of information from different providers, from different stakeholders, transport networks, in a single application. And of course, it leads to a reduction of waiting time and planning time, travel time also. Well, but this is not only for the users, it's also important, very important for the smart city. So, according to the European Commission, which is for which it is a very important topic, so there is a dedicated transport team in the European Commission ICT agenda. There is a topic which is called Intelligent Transport System, where they have a specific action plan devoted to the promotion of multi-modal journey planning. They work very actively there. What they do is that they try to analyze, provide the guidelines for the cities, for urban zones, but also for national levels, and what is more important, for interoperability between different planners. So they try to work on the standards together with the providers, on the standards for data formats to exchange between different planners, so that the integration becomes much more seamless, much simpler. As for the smart city, it gives a lot of benefits, like network efficiency and ease of moving easier moving of the person and goods in the region. It provides support for accessibility and development of the town. So just according to destination, just the multimodal planner tools contribute like more than 5% of the modal shift, so to the shift from the private car moving to the public transportation. If the system is done well, they say that it contributes 5% to the and it leads, of course, to the increase of socio-economical impacts and environmental impact, as well as allow the city to reconquer space from the private cars to the eco-friendly transportation modes and urban planning of the city, so it leads to more socialized cities, let's say. And so, as I said, the EU is very active there, and last year there was even a Smart Mobility Challenge, which was devoted to promoting different journey planner, multimodal journey planner tools. They had like 30 submissions, and there were 4 winners, 2 for ideas and 2 for planners. So these are very important things for doing this kind of systems, and of course we had to do this in a SmartCampus. So we had this question, how we can do this? So what do we have? We have a set of requirements, and as I said, these are real-time information, possibility to plan in a customized and a personalized way, possibility to involve the community for crowdsourcing of information, of delays, updates of road situation, and so on. And support also eco-friendly modes like bike sharing, car sharing, and carpooling. These were the requirements. We had a lot of local players in Trentino. It's of course Trento, Inter-Transport, it's Django, which is this social mobility service for sharing a car. Official car sharing Trentino service and carpooling. So there are private taxi Trento. So the original idea was to try to provide the support for the integration in a single system, contribution to a single solution. Of course, this is about the requirements and starting points, but what about the tools available? Well, all those planners that exist in Europe, they are provided by commercial vendors, and there are a lot of players in this market. They provide, all of them provide closed solutions, private solutions, and more active among these probably Apple, which is a German company which provides solutions for Italy, for Great Britain, and also for Germany itself. Well, Google, some other companies, there is also two services, which is Italian one. And of course, we thought that it is not possible that we go there and buy a solution, because it was a research project. We wanted to experiment, we wanted to try what we can do ourselves. So we looked at the open source project, and well, quite surprisingly, to the certain level of maturity, arrived on the 2. Even now, there are only 2 quite mature open source projects. One is GraphServer and another one is OpenTripPlanner. Well, there are some other research initiatives, but they are still in the, let's say, in the form of in-house. So there is in state, in one of the universities, they work on the planner for their local one, but it's not a product that it's not a open source product that they release, and you can access the code and you can experiment with. So we took one of these open source projects and started creating these things, and there it was SmartPlanner. So it's a tool that is being developed, continuously developed by the service spin-off of FDK. And based on the requirements coming on both from SmartCampus and from it's an open source tool, and we are continuously working on this. Now I will speak about how we implemented this, what is the functionality and how it works.
Thank you, Raman. As Raman has already spoken about multimodal transportation systems and the need for having such kind of system in the context of the SmartCampus project, I will briefly describe how these kind of multimodal transportation systems works in general. So it includes graphical representation of the networks of path and uses in routing algorithms to find the best path between giving the user constraint. And the search problem is actually divided in two steps. In the first step of geocoding, the requested source and destination addresses are translated into geographic coordinates such as latitude, longitudes. Reverse geocoding is the process of converting these coordinates back into human readable form. Then in the second step, it involves route calculation on using routing techniques to find the best path between these points. And each path in this graphical representation has a weight which may vary with the optimization criteria, such as distance, time, safety. So, how we approach this problem and come up with a system that provide all the needs, that meets all the challenges. So we basically started with the analysis of existing open source multi-modal trip planner system, libraries, tools, and we came across two open source tools in this area, Graph Server from the Graph Server organization and OpenTripPlanner, which is a result of a collaborative effort among TriMet, OpenPlans, and the developers from 5 Points, One Was Away, and Graph Server. In this slide, I've tried to summarize the analysis in the form of table features such as search criteria, data source, compatibility, licensing. Both these tools provide the basic routing functionality, means that they both have a way of creating a graphical representation of the area and invoking algorithms on these. However, from the analysis here, it appears that OpenTripPlanner is a rich tool in terms of feature. So, in terms of data sources, compatibility, licensing, and programming languages. So, we basically tested both these systems with sample data, and we opted for OpenTripPlanner as the core engine in our settings. We then further analyzed the OpenTripPlanner in terms of support for real-time data, efficient communication with the community of users, additional modes, and route data information such as timetable, delays. And we figure out the set of provided features which are shown with the green border here. So the OpenTripPlanner currently supports multi-modal walk, bike, bus, trains, and transit trips functionality, and it takes travel time, road type safety, and elevation data into account when planning for bike and walk trips. It plans in about 100 milliseconds in a moderate sized city like Trento. It exposes RESTful APIs on top of which other application or front-end application can be built. It provides a driving direction taking into account the regional speed limits. For example, 130 km per hour on highways and 50 km per hour on urban roads. And beside it provides routing criteria, optional routing criteria, fewest transfer, quickest transfer, or maximum walk distance to the public transportation, and it provides translation in different languages. So these in this slide you can see the set of provided features. The OpenTripPlanner uses data from many different data sources. So it uses the transit data from the general transit feed specification, the street data from the OpenStreetMaps and shapefiles, the elevation data from National Elevation Data Set and geographical regional models, and it integrates these data into form a graphical representation. General transit feed specification is a common and open data for spatial and schedule needs for trip planning itineraries. And this data was initially and collaboratively designed to be used in the Google Transit service, which now has more than 450 participating cities worldwide. Although the data, the protocol itself is created under a Creative Commons license, the decision to make the actual data open is made on agency by agency basis. So how this general transit field specification data looks like? It basically creates, it basically is composed of a series of text files, as can be seen here. And in each of these text file models particular aspects of the transit information. So it contains information about the agencies, about the routes, the trips serving the routes, about the stops involved in these routes, the stop times schedule, the calendar time specifying the dates that this service operates throughout the year. And with this data, it actually empowers the trip planner systems and timetable publisher or any other application, too diverse to list here, which in some way uses these public transit information. OpenStreetMap, the other kind of data used, is basically a collection of geographical facts. It is a seamless map used for routing purpose. It is licensed under Open Common Database license, and OpenTripPlanner uses elevation data from geographical regional models to create it and to somehow show the elevation profiles of the trips. So how these different kind of data works? So the OpenTripPlanner basically identifies the extent of the areas from the data set, and then it automatically grabs the necessary network coverage from the data source of OSM and elevation data to create these graphical representation, which is technically called as a graph object in the settings of trip planners. And these graph objects contain all the locations and the path between these locations. A street is divided into a street segment. A street segment is a portion of the street between two intersections. What kind of user can traverse on these street segment is specified by means of attributes, common properties, such as permissions, road safety. Basically, a user can, each importer has its own way of configuring these properties. For example, for instance, a particular street segment can be traversed only by bikes in one-way direction, or another street segment can be traversed by only vehicles, not by pedestrians. So these kind of attributes helps in determining the street travels and permissions. And as a result of the integration of this data, you have this graphical representation, which is then used for routing purposes. And these components provide the functionality for compiling the graphs from the data sources, data sets, and the routing algorithm for invoking finding the best path. The logic component is on the top is the one used for loading and using existing data set, which can be a transit graph, it can be a transit schedule. Narrative engine is the part that prepares the final human readable trips from the path through the graphs. The data sources can communicate with the narrative engine, allowing for trip advisories to be overlaid on the final trip if required. And the most important component is the API component, which exposes the RESTful APIs and it responds to the journey planning request with the itinerary in XML and JSON representation. This is the part which can be integrated with a UI, user interface, or other application can be built on top of these components, directly communicating with it. This is a servlet which can be dropped into any sublet container. So, in this slide, I present you the SmartPlanner engine, which is instantiated with a vision to meet the challenges of mobility requirements. And it is an open source information system that provides multi-modal trip planning and real-time data generated both from the system and the user. And it not only integrates the feature from the OpenTripPlanner, as the feature with the green border are the features provided from the OpenTripPlanner, but it also provides the rest of the required feature in the mobility world we need. So the feature which we're missing in the OpenTripPlanner 2 were real-time updates, route data information, additional support for additional modes. For example, bike sharing and car sharing are very popular modes in the metropolitan city today, and an efficient communication mechanism with the community of users. So in the next slide, I'm going to explain briefly about these features and how we implemented these. So the SmartPlanner engine has the ability to respond to the real-time delays, and if in case due to user error, for example, user missing a bus, or due to a service delay, it is a need that the planner must give the user an updated or a new plan. In SmartPlanner, we have handled these problem, and we basically maintain the repository of real-time feeds and expose APIs for creating, viewing, and update these feeds. The source of these feeds can be a user or can be a system. So we have both the user part and the system part. We have engaged special services that collect information for these delay feeds. We had to develop special kind of connectors for communicating with this kind of services and bringing the data and injecting into the SmartPlanner engine. But what is important here is that we not only take into account the certified services, but also the user aspects, collecting the user information and bringing it into the engine. And the engine then transforms these information into real-time feeds and use it in planning decisions. I have to say that we at the moment does not directly use the user input into the planning decision, since we yet have to find a way to manage the security and trust aspects. But what we do is that we generate useful notifications in the plan in case it's updated from a user, and however the input from the certified services are taken into account in planning decisions. So the alert delay is actually is mapped to the trip ID, and which is unique in the itinerary. And on the engine side, we keep on saving and updating these alert delays. This alert delay contains special attributes like start and end time. So given a user request, we invoke the OpenTripPlanner engine to get an itinerary, and then we post-process this itinerary, traverse through each transit leg and identify if there exists an alert delay associated with this leg in our repository internally. And if the start time of these leg or this transit trip falls within the validation period of the alert delay, we add this delay to the transit trip. Not only that, we add it to the overall end time of the trip and to the entire duration, and we make a consistency check with other legs and give the response back to the user. Besides, we expose the APIs for doing all such kind of information from the repository. We in the SmartPlanner engine, we have the support for parking-based planning and to get the real-time status of parking structures, as it is useful for user to plan with such kind of information. Park and ride mode is a very famous mode in metropolitan cities. So basically in this mode, the planner gives you a driving plan from your source to the nearby, to a parking station after searching for a parking station near to the destination. And then it proposes you a transit plan from that station to the final destination. We maintain a repository for all the parking stations and a repository for parking alerts. And we expose APIs for viewing, creating and updating these structures. Again here we take into account both the user part and the service part, and the motivation is the same, to have both the user and the service aspect into the car and bring them into the system. And then we make planning in pre and post processing phases to achieve the goal. So for example, if a user is standing at a parking station and he finds out that there exists no more post in the station, he can, using the notification interface, can notify to the engine about it. The engine translates this notification into a feed. These feeds contain important information like it is mapped to the station ID and contain attributes like number of available posts and the validation time. Then on the engine side, it plans for a nearby station given a user request. So we have this support for geospatial search. So we search for a parking station near to the destination and validate it with respect to number of available posts. And then we invoke OpenTripPlanner to get a car plan for these from the source to this destination. We post-process this plan and add any notification. For example, a notification saying that the number of parking places are few. So we have a threshold value on which we act upon and communicate to the user these notification. And then we propose the transit plan from the parking station to the final destination. This is how we realize in pre and post stages of the planning. Besides, the engine exposes the API for viewing all the status of the real-time status of the parking places around the city. The SmartPlanner provides support for other kind of notifications. For example, in case there is work in progress or route changes, accident, nowadays we often see strike calls. So this kind of notification is helpful for user to plan and to act upon. So we, as a SmartPlanner engine, implement these functionalities. So we have a repository of notification feeds, and we expose the APIs for creating, viewing and updating these feeds and bringing them into the system to make in the decision process. For example, and again here the motivation is the same, to manage both the user and the service aspect. In Vivi Fiemme project, in Nordic Sky Championship project, we had a special kind of feature, the vehicle capacity, that allows the bus driver of the public transportation system to report about the capacity of the bus. So the bus driver, using a push button system, can trigger the level of occupants in the bus, and this is taken in by the SmartPlanner engine, and it store it into a notification feed mapped to the trip ID. And on the engine side, when it plans, it checks whether there exists an alert capacity for this vehicle, and notify to the user if the capacity is of medium nature. It appends a warning. However, if the capacity is full, it simply ignores that plan. So this is something we implemented and tested in the context of the Vivi Fiemme project. Besides, the SmartPlanner engine has comprehensive real-time multi-modal information API. A timetable basically gives information on service times. It it lists down all the service time to and from particular stop, and it may include all the movements for a particular route, or all the movement to and from a particular location. And not only that, it must be dynamic, so it must take into account the real-time delays of the services and somehow display it or provide this information to the user. We have integrated these, we have built this functionality, and we also have the functionality for geo search support. And this component exposes an API that provides information deriving from this GTFS data set. Example of such API can be finding all the routes in a particular area, on all the trips serving a particular route, or the timetable for bus for a particular stop in coming 5 minutes, or getting the nearby stop to the first to a location. So the picture here, the PDF timetable, is the one you all are aware of. Is what we used to see at the bus stations, and we used to download it from the Trento website. And it's a traditional way of reading the bus times. What the SmartPlanner engine has done, that it has provided an electronic version of this timetable, which not only gives you the schedule data information, but also the update about the real-time service delays. So this API is integrated with the SmartCampus application, and this kind of information can be viewed from the SmartCampus application. Besides, the SmartPlanner engine supports additional modes, support for bike sharing and car sharing modes, which are very popular in the metropolitan cities. And basically, a car sharing mode works like this. The planner gives you the planner first searches for a car sharing station near to the source, and then gives the user a transit plan from the source to this car sharing station, and then a car plan from that station to the final destination. We in the SmartPlanner engine maintain a repository of rental stations and rental station updates, and we expose the API to create, view and update these alerts. So at the startup of the engine, we initialized all the rental stations, and the API waits for coming alerts. So basically, if a car sharing service notifies that there exists no more no more rental vehicles in the parking or in the rental station, this information is injected into the planner, and the planner takes the decision accordingly, ignoring that station, and gives user another station nearby. So besides, the engine exposes all the APIs to view the status of all these stations and all the updates. This is another interesting feature, especially with respect to Trento. With respect to Trentino, which is a mountainous region. So right now in Po, we are at an elevation of around 400 meters. So it's a nice idea to go by bike or by walk to downtown, but it's certainly not the same coming back, at least for me. So having these kind of elevation information in routing itineraries is a need, and the SmartPlanner engine supports these. The feature is provided in the OpenTripPlanner, and we have generated our the geographical model for the Trentino region with all the geographical metadata, and this data was used during the building of the network of paths, and with these we have the possibility to see the elevation profile. We at the moment we have all the kind of information about elevation, related to elevation in the trip planning. I have to say that we at the moment use the impact on the time when planning for walk and bike trips, but we have other information related to the elevation profiles, and we will integrate these in future. Now, so the SmartPlanner architecture, which is composed on top of OpenTripPlanner engine, enhancing its functionalities and customizing the planning flows and implementing all the mobility related functions. The OpenTripPlanner engine is contained within the SmartPlanner engine, and it directly interacts with it using the RESTful API calls. The core components of the SmartPlanner engine contain all the modes supported by the planner engine. So all the modes, the one integrated from multi-planner and the one created in the pre and post phases of the planning. The GeoManager component, the component that provides functionality for geocoding and for geospatial searches. So it uses MongoDB geospatial features, and besides it exposes connector for different kinds of online available geocoding APIs. The root data manager components manage all the data set related to the transit field specification, and it provides interface that provide information derived from this data set. For example, information on routes, bus, timetables. So this component is basically in charge of handling these kind of functions. The repository manager is the manager of all different kinds of collections in the system. Collection for alert delays, route data, parkings, notification strikes, and it exposes API for other components to interact for, basically to create, update, query the repository manager. And the planner is the component that exposes the interfaces to the outside world. So it is the gateway for the SmartPlanner engine. So it exposes APIs like planned trip, recurrent journey, alert delays, alert parking. Besides, it gives reset functionality to reset the repositories, route API information. Recurrent journey is about planning, about monitoring your daily trips over a period of time. So the engine provides the information about the list of transit trips that a person can take, and then this is then monitored in the context of this feature to update user in advance for any upcoming notification and so on. So this is all about the architecture of a SmartPlanner engine, and we have used this engine in the SmartCampus project and in the Vivi Fiemme Nordic Sky Championship that was held in February 2013 this year. And to tell more about it, I would like to invite Raman.
So, how we use this engine? How we instantiated all these features in the practical settings? In the SmartCampus, well, the application, driver application is Viaggiarrento, which is actually the mobile Android application to provide the user visibility to plan, be informed and be notified about the movements in the region. And the basic functionalities refer, of course, to the planning. So what you can do is you can have multimodal planning. If something you can see here, so you can have some results, and this may include the public transport, the bike sharing, the navigation to the parking places, and so it provides the detailed information of the trip and also provides information about the real-time situation of the trip. So, for instance, in this example, you can see that there is an alert for the train leg of this trip, so which is of 3 minutes. The trip is still there, but it just informs you that, look, there is a delay and it probably can increase take this into account. So can you plan if this does not impact the result of the plan? You will be working in this kind of notification. And of course, you can see the plan on the map. Then another important functionality, the possibility to have real-time information. And there are two kinds of those. Well, the information about Trento parkings, and you can see for a set of parkings the situation about the places available. So for instance, green, gold in this case mean that there are quite some places still available in that parking, while yellow one means that they're about to finish, and red normally means that there are very few because the parking is full. Another part is about the timetables and real-time timetables of bus and train routes. For instance, we have covered all the buses of urban buses of Trento, the city of Trento, and several fragments of Trenitalia lines, including, for instance, Rome to Bolzano, Trento to Bassano del Grave, and so on. And all these timetables, apart from providing detailed information for the next trips, for the next 2 days actually, it gives you the information about the current delays. So these delays, as you can see here, for instance, this particular train is 7 minutes late. Of course, this includes both the information arriving from the external certified sources, so from the providers directly, like the information about the delays of Viaggiarrento. They have a website which we scrape and extract information from about the real-time delays. The same for trains. For the buses, we don't have this information yet because the transport system does not provide this kind of API or some kind of information. Also internally, I don't think they have a complete system working with that. But the user has a possibility to signal in himself the fact that there is a delay or there is a cancellation delay and currently supported about a particular bus or a train. This kind of information is handled differently, of course, but still you can be informed, and you will see the information goes from the user in the system and the certified providers in case of timetable. Take a trip every day from home to the university. You can save a trip with some parameters, select which lines of this trip you would like to monitor, meaning you would like to be informed about the delays of line number 5. And then we have an application functionality that provides you with a notification. So the system will inform you the date about this, the delay of this particular line. So, some synthetic data about this. So we covered the Trentino and some other parts of the territory, so up to Bolzano and to Verona, as an area for planning. It includes several modalities like train, city bus, Vivi Fiemme, and bike sharing. It includes real-time data provided by Inter-Modal web service that we inject into the SmartPlanner engine, as well as the train delays that we extract from the other sites and from the users. And this system includes elevation data, as I must have mentioned, with a resolution of 30 meters, so it's quite a detailed one for the trips, for walk and bike trips. And just to give some numbers, it includes like 300 routes meaning lines actually, so Trento, Bassano del Grave is one line, number 5 is another route line, so this kind of routes, and about 4,600 different trips, not counting for the graph data which is provided by OSM. And we are still working on this. We are still extending this. We continuously extend this application in the SmartCampus. So the new functionalities refer, of course, to intercity bus, which is very important here in Trentino, but also go beyond this kind of information and try to consider the further means of transport, like car sharing, further means of information like grid points and carbon footprint, and how to use this information in gamification of the application. So how to make this involvement of users in the application lifecycle more On the Vivi Fiemme, there was implementation devoted, there was part of the implementation of the application devoted to mobility. Of course, planning and real-time information were in the focus of the application. The specific things implemented there were concerning different types of transportation, ski buses, ski lifts, and intercity buses, already integrated in the application. It covered the area of Vivi Fiemme plus the city of Trento and some other important cities of the region. It includes real-time data from parkings and, as I mentioned, vehicle capacity for shuttle buses, and information provided by the users. So, in order to integrate these, there were some other applications implemented, like for the parking managers. There was an application to signal the fact that parking is about to flow, about the numbers of the places remaining. The data is compactly the same in terms of number of trips and the routes, and the application was deployed and had been used during this implementation. So, about the perspective of the development of the engine and OCUs, where there is a lot of space of improvement and interesting things to be done. This concerns the information to be integrated, and here, as I said, we can think about green points, or carbon footprint, fares, and accessibility data, which is very important for social aspect of the application functionality. More transport networks to be integrated, as car sharing, pooling, booking bus, Django, taxi, and so. More services to be integrated, and here we speak about the services related to mobility functionality, like reservations, ticketing, more real-time data providers, not only from the big ones that we have, but also for the other ones. And of course, more interested and optimized algorithms to be integrated in the planning and the management of the plans, like advanced use of patterns. So strikes is a simple example, but accidents in roadworks impact a particular line, particularly the user interested in. How to optimize and further parameterize the planning options so that we can have more flexibility on the client side to decide what kind of plan I want, what is more important, what is less important, and play on this side. So these are perspectives of both of the engine and of course use, and we would like to thank you for the attention.
So we have time for just a few questions.
So my impression is that you have identified a series of basic services, okay, but then it's really a moving target what you are here. I mean, you can imagine to expand with more feature, integrating more services, etc. forever, basically. Okay. So do you think that it's better to open the application and allow people to plug in maybe their own service or their own feature that they would like to add, and then integrate in your application? For example, if I come from a small place around Trento, I know exactly the timetable of few buses, and I want to integrate it with the timetable of Trento, for example, because I want to come, I arrive in Piazza Dante and then I want to come here. So, do you think this is feasible?
Yes, and there are several directions for this kind of openness and extension. First is the level of the SmartCampus platform in general. So it was developed, it was born to be an open platform for development. So the API of the engine and actually the engines of the open source and the API provided. About the extensions of this kind, you can work directly on the platform level. We welcome service providers and information providers. We welcome also the developers to participate to this, both on the server side, so implementing new functionalities, contributing with data, contributing with new data sources, extractors, and kind of things. And also on the client side, where one can take the API that they exposed by the application and to modify it, customize or extend, implement specific functionalities like a specific widget for specific line, for specific problem of territory or something like that. So these kind of extensions are there by design.
You have another one? So maybe you or your colleague has mentioned about push notification, right? And this is something that is worrying you from the point of view of security and trust. So can you expand on this?
But this, as I mentioned, this was the notification for the drivers of the bus. So basically we allow the driver of the authorized person to notify this kind of notification.
I thought that this push were about the delay, for example, of trains.
This push is provided in the transport and in the station system that was meant to be used by the drivers.
This is one of the implementation. Another thing to which Silvia probably refers to the one of signaling the delay for transport directed by the user. In this case, yes, the trust is an important issue. Well, for the security, only authorized users can signal the information. So authorized means authenticated and one that are part of the campus. On the trust, it's a very important problem, and how we manage it currently, which probably will not be the final solution, ultimate solution, is that we distinguish between the notification provided by the services or by the certified providers, like the company that manages the transport network, from those that are signaled by users. The ones that managed by the providers are taken into account when I plan. Okay, so if there is a delay of 20 minutes and with this I will lose my next leg, of course this will not be returned to the user. While for the user kind of notifications, we still return the plan, ignoring somehow this signal delay by the user when we plan. But in the result, we annotate the result with this kind of information. Look, there was a 20 minutes delay signal by the SmartCampus users. The aspect of how to make it more sophisticated and smart is still open question, because there are things that you can do, like for instance, allow the other users to vote or like, dislike the signal. Okay, so you signal it was half an hour, and others say it was not true. It was I like this or I don't like this, or this kind of thing, in order to increase the confidence about the particular person, about the particular community, and so on. And then bringing this confidentiality into the plain algorithm in the result. For the moment, we just annotate the result with this kind of information, but we don't push it to the end users in the hardware.
Okay, thank you all. And the next and final seminar for the Smart City seminar series will be in 3 weeks on
Final before the break.
Final before the break, yes, for the summer break. Will be in 3 weeks here and will be held by Maurizio Napolitano, that will speak about open data and open data movement. Thank you all.